In particular, and of concern for this boot camp specifically, we're going to start focusing more now on oceans. And what we're starting to see is increasing surface temperatures. In these maps that just flashed through from 1890 to about 2007, what we're slowly seeing is 1 to 2 to 3 degrees increase if you're doing Fahrenheit and versus Celsius in the surface of the temperature. We'll see the sea surface temperatures worldwide as a result of these increasing greenhouse gas effects. So it's basic physics 101. If you increase the sea surface temperature and the ambient temperature, the air over the oceans, you're going to see an increase in evaporation. So you're going to see more water vapor. Humidity is what we tend to call it. The change in sea surface temperatures is also going to change the ocean circulation. We're going to see a lot more rainfall. We're going to start seeing sea ice melting, and that is going to change the volume in the ocean. The heat content of the ocean is going to increase. On land, we're starting to see glaciers melt. That's bringing more water down to the ocean, so it's also increasing the volume. And we're starting to see the temperature increase over land, which is just accelerating the air surface temperatures over the ocean itself. So as a result, we're seeing right now sea levels are already changing. This is a picture from the North Atlantic area. It's called blue sky flooding. It's one of the things where the high tides are coming in at the highest ever seen, and some of this is due to changes in the glacial ice pack, but also volume of the oceans, as well as the Gulf Coast, the current is shifting. So we have, and we know for a fact that we have historic proxies that show what the temperatures were like way back when, hundreds of years ago. In the mid-1875 timeframe, we started putting gauges out into the system, out into the ocean, so that we could start tracking and monitoring what was happening in terms of levels in the oceans. Around just before 2000, we started placing satellites in orbit, and we started getting digital feedback from those satellites about the increases that we are starting to see. And then there are global climate change models that have been run every 4 years. The IPCC, in effect, either reaches out and pulls those models together, or has in the last 4 years funded some of the modeling to start forecasting into the future what we can expect to see. There are several reasons why we're seeing these changes. We're seeing added water mass, as I mentioned, by the ice melt. If you heat up water, it expands. So we're seeing something called thermal expansion, which causes a change in volume. And underneath the oceans, the ocean basins are still shifting. They always will. And that is causing some changes. Also, when the ice melts off of continents, the pressure is released off those continents and they float up. And so that's called isostatic rebound. And so we're seeing some of that kind of shift and change, which is all leading to kind of an ever increasing rise in the global mean sea level.